Over the course of human existence, the biggest contributor of revolutionary and industrial growth was our ability to draw energy from our surroundings. One of the biggest catalysts on that front was the invention of the steam engine that helped power the Industrial Revolution. In the early 1800s, steam engines were used in factories to power large machines. Later on, machines were fitted for transportation. Today, our group will attempt to bring back the steam engine and attempt to power a model vehicle.
The steam engine purchased online consists of a closed cylindrical chamber where air is heated. The expansion of the hot air pushes a piston which is then translated to rotational energy by the flywheel. Once the air expands, it rapidly cools, allowing the volume of the chamber to increase, and the cycle is repeated again. Our goal was to determine whether the torque produced by the flywheel can exceed the inertia of the car. The torque can be written as force times the radius of rotation, which can be further broken down as the work done by the piston over its length. Using the first law of thermodynamics, we can write the work as Q minus delta U. Using the respective formulas for Q and delta U, we get the following final inequality. Delta T times the quantity mc minus ncv divided by the length of the piston, multiplied by the radius of the flywheel. That must be greater than the coefficient of friction of the cardboard times the mass of the car times gravity. We made several assumptions during our calculations. First, the volume of the piston and the mass of the air inside were both rather approximate calculations. Also, we ignored the internal resistance of the ball bearing and the wheel. Finally, we assumed that the translation of the torque from the flywheel to the wheel of the car was 1-to-1. We built a model car from cardboard and connected a ball bearing to one of the back wheels, which was then connected to the flywheel of the steam engine. As you can see, we were not successful, and we went back to our calculations to determine where we went wrong. Professor Faridian was kind enough to help us acquire another steam engine in order to open it up and investigate its internal workings. We took actual measurements to use instead of theoretical values. Using a caliper, we measured the volume of the chamber, which we then used to find the mass of the air inside plus the number of moles of air it contained. Clearly, the mass of the car vastly exceeded the output of the engine. We further calculated that using our setup, the engine could move a car weighing no more than 20 grams, approximately the weight of 20 paper clips. This is why we were unable to move the car. In the future, to reduce the variance in the experiment, several steps could be implemented. First, using a simpler and easier to assemble car, Legos for example, would cut down on variables in the stability of the car itself. Furthermore, the rubber band method that we used of connecting the wheels introduces unnecessary friction which could be eliminated with a better fastening system. Thank you for watching our video, and we hope you enjoyed it.